All right. Good morning, good afternoon, good evening, everybody. Welcome into the Dragon Den. I am Digital Dragon, aka Luke, and this is a 3D printing channel where we do everything from printer builds to cosplay helmets to other 3D printed parts. Let me kick a light on here real fast. How's everybody doing this morning? I am doing well. It may wind up being a little bit shorter stream today. We'll see how my endurance holds out. Good morning, Timor. How are you doing today? In your seat, waiting for the bell to ring. Awesome. Just to see my face and hear you. Aw, you're getting me in the feels again, man. Careful. So yeah, we'll see how well my endurance holds out. Because I was up till about 3 a.m. this morning working on the printer. And you go, 3 a.m., what were you doing? Well, I got the wiring done. That wasn't the issue. The issue was the Radsa 1 that I was using and couldn't get it to talk over UART. And then the Banana Pi, where I was having the same issue. And I finally figured it out. So we will chat about that a little bit. I'm going to see about some people coming in. But yeah, it was a very long night. And not a whole heck of a lot of sleep. So yes, science. It was fun to say the least. So yeah, it was one of those things that I got caught up researching stuff, trying to find stuff on YouTube, trying to dig around in forums and getting my Google Foo out. And you'll see that we still have a little bit to do to tidy up on the printer. But all in all, this was a hell of a build. I will say that there are plenty of extras. I mean, I think they gave me enough M3 nuts to do like, I don't know, 12 of these. But there's plenty of gubbins left over after this build. And I think it may have been because they don't know how you're going to build it. Is it going to be a generic Rook? Is it going to be with the Fabreeko files? Did you get a 2020 kit? Because if you get a 2020 kit, then things are going to mount on the 2020 differently. So the extra bits and gubbins, no problem. They'll get thrown into the bins, because when I go to do the next Rook, yes, there's going to be another Rook. Remember, kids, we've got a Rook 2020 frame sitting over here that came with this. And the intent, I believe, from Fabreeko when he threw that kit in was for me to actually build the Rook kit using the 2020 frame. And you know me, why do things easy? So I've got, as you all have seen, we've got Gold Dragon, which is a Rook Mark 1, and this is a standard build prior to the kits coming out and stuff. So this was all self-sourced. It uses a BMG extruder, and it prints well. It was printing at Murph up until the time that the power brick ate itself. So I'll have this version with several mods from Gulsifer, and then I'll have the Rook Fabreeko kit, the Bear Rook Fabreeko kit, which let me kind of flip these around and show them side by side, right? So you've got different idler pylons up here, different feet. This is going to have skirts that'll go around it with an underslung mounted power supply, which is, you know, sitting right here. We'll talk about that later. It's wired up to the switch, but we're actually still using the DC brick for right now, and I'll explain why. But yeah, I mean, this the Fabreeko is running the SKR Mini E3D This Gold Dragon is running the SKR Pico board with a Raspberry Pi Zero, where the Fabreeko is going to be running the SKR Mini E3D and in this case a Banana Pi M20. So there's a bunch of different types of Banana Pis. This version of the Banana Pi doesn't have eMMC memory. So it does use an SD card. The Radsa 1 that I have is the same form factor as a Raspberry Pi Zero. It's a little bit faster than even the Banana Pi, and it has 2 gig of memory and 8 gig of eMMC flash on it. So we'll wind up using that one in our next Rook, which will be on the 2020 frame. So yeah, that's kind of the compare contrast. So yeah, let me go ahead and get this one down, because this is our focal point. This is our Fabreeko Rook kit. The Rook is a mostly printed 3D printer. It's made to be printed out of, well, it was originally designed to be printed out of PLA. Gold Dragon is PLA. This printer was printed in ABS. Normally on my printers that or anything that I print that was designed for PLA, I normally print ABS at 100.5% scaling in all directions to account for the additional shrinkage. It is using a custom toolhead board, or custom hot end, which we're going to have to take our fan shroud off here to get our bowden tube in still. So that's something we need to do. It does use the LDO Motors Polymide V0 bed. And because of that, that is why we have the external power supply. Because that polymide heater uses more power, we really need to be running things off here when we go to heat this up. I did attempt to heat it to make sure that, just validate wiring right before the stream. And it does heat, but it heats incredibly slow right now coming off of this 24 volt 8 amp brick. So this is a 24 volt. What is this one rated at? I want to say this was a 24 volt, 8.8 amps. Yeah, this is a little bit more there. And I may also have a couple of settings different, because what I did basically was took a lot of my settings from Gold Dragon and ported them over. Kept all the pins, the pin assignments, but ported the actual config stuff over. So we're definitely going to have to calibrate our E-steps on our extruder. We still need to make sure that the extruder motor is going in the right direction. I did get everything, and sorry folks, I'm trying to finish off my breakfast. So primarily a liquid breakfast this morning because I was running so late. I did get everything wired. It is up and running right now. In fact, I will just raise the bed up by hand real fast and I'll do a home all. Bed drops. We go to the right. We go back. Bed will go down and do its homing sequence. So we are pretty good. Now with that, I am going to go ahead and shut it down so that I can show you some of the wiring and how I ran the wires around and everything. And we'll do the last bit of stuff underneath the deck that we'll need to do. And by the way, Free Heathen Timor, how are you guys doing today? I hope you guys are doing well. Thank you for being in here. I see Nick's here as well. Steve 3D's here. Thank you all for coming in so early on a Saturday morning. So we told it to shut down. We're giving it a couple seconds for it to do its thing. And then we're going to, without touching any of the exposed metal pieces, just unplug our DC power, set this off to the side. And I'm going to flip this over on its back and turn it around so you can kind of see some things. Okay, and I should have made a different, we'll see if we can't get you guys a little closer here. Bring you down on its level. Okay, so we got that there. Yeah, I'll just lift this up a tad bit here. So we've got our two wiring looms that are coming back down the side. We have the primary one coming from the tool head, and then we have another that picks up all the motors and stuff from the top back and comes down. Those wiring looms, the motors kick off and go over to the side. I put a little sticky, a sticky pad that is a zip tie holder. So I have one over on this side and one on this side. And that allowed me to hold these two out of the way because eventually there's to be a fan right here on these little ears, right? So that'll be a cooling fan for the board. Those wires are tucked nicely down here, and then down here in the front, there's zip ties holding the wires in place. And I did go through and cut all of the wires to length, revalidated all of their pinouts, so everything's in place and working right. The other wiring loom that's coming from the tool head comes down this side, and that's what breaks out down here. So we've got the hot end, the heater bed, we've got our part cooling fan, and then right above it here is the hot end fan. Right next to it, between the screw terminal and that, there's another fan connector, and that will be for the cooling fan that'll go right here. Okay. Over here, we've got the Z end stop, the bed thermistor, and then this last one right here is the hot end thermistor. And then you'll see that we have our Z motor wire. We just brought it down around. It gets caught in one of the zip ties down here and comes around right to there. So you've got X, Y, Z motor, extruder motor. And then our Banana Pi 0 is going to get mounted right in here, and we are using a UART connection. And we're using a UART connection, which in this case, starting on this back row of pins, starting in the second pin, which is pin 4, we've got 5 volt, ground, transmit, and receive. And your transmit and receive wires get rolled when you connect it to your board. So the connector on the board here, we're using the TFT connector, and from left to right in the way you're looking at it, it's 5 volt, ground, transmit, receive. So you want the transmit from the MCU going to the receive on your Pi, and then receive on your Pi going to the transmit on your MCU. So you want them swapped. And this is a very easy cable to fabricate. This is just some of the spare motor wire from the extruder motor that I cut off when I shortened it. And it's just DuPont connectors on both ends. Yeah, good morning, Nick. Hello, Happy Todd. Welcome in. Thank you for the first time chat. Thank you for joining us. Poon Dog, how's it going, my friend? Yeah, I've got some pictures posted on here. We will get you some pictures for Whip Sunday. I have tensioned the 4XY belts at the top. I have not added any more tension to the bed. I could probably loosen these screws, give it a little bit of tension, not too much. But we need to mount our Banana Pi 0 in here. It's going to use some M2 by 10 self-tapping screws, and it's just going to tap directly into the plastic. And once we get that done, then we'll be able to go ahead and mount our power supply, which, looking at how everything goes, I believe we're going to mount the power supply in this orientation. So I just left all the wires long for now. Once again, the switch is connected in, but this is not connected, and I haven't applied any power through the switch yet. I've just been using my DC for all my initial testing. So what we'll do is we'll just take these out, and we'll either create some new wires to go into this, or we will just cut the ends off this, add spade connectors to connect into our power supply. That's kind of where we're at. I'm going to lift you guys back up. Back working on the 40G projects. Sweet. That's going to be awesome. That's going to be awesome. I'm looking forward to seeing all those. And Timor, the 0Gs, refresh my memory, these are the Ender 5 converted ones, right? Not the scratch-built frame ones that are in beta test right now. Yeah, let me get this propped up on something. And we will there we go. I'm going to just try and move this out of the way. And once again, we're going to mount this. Now on the Banana Pi, an external antenna is a must. It will not work unless it is like sitting right next to your wireless router. You may be able to, like the first one I did that's downstairs in the Bugaboo, I was able to get on the network, and that was about it. I couldn't do a sudo apt-get update. I couldn't do a upgrade or anything like that until I got an external antenna in it. This one, I couldn't even get connected to the network without the external antenna. Once I had the external antenna, it saw the network, it couldn't connect. So the Banana Pi definitely needs a external antenna. And you do want to make sure that you get your heat sinks on it. It runs hot and it will thermal cycle if you don't have the heat sinks on it. The Radsa Zero, so let me grab that board. Once again, same type of form factor. It uses a S905Y2 main processor, where this one uses, where the Banana Pi uses an Allwinner core processor. So this has a slightly different processor. I've got Raspbian on the Banana Pi, I believe. And no, I take that back. I believe it's Raspbian Bullseye. It's an older version. They don't have the newer versions available. They've stopped the development of OSs for these boards. Oh, nice, Timur. So yeah, you're doing some Frankenstein stuff. Hey, good morning, Rob Mink. How are you doing? But this board is actually one of the fastest Pi Zero replacement boards you can get, being the Radsa Zero. The only issue I had with both of these boards is trying to get them to talk over UART, because there's really not a lot of room in here to try and do a buck converter. And then your only option would be to run a wall wart separately to power it. And if you're going to do that, you might as well just do a Raspberry Pi sitting on the side. So what we're going to do is we will mount our Banana Pi board in here. And I think we're just going to mount it like this. That way we have access to our SD card. We'll mount it up here like this. This wire is way longer than it needs to be, but we'll just fold it out of the way. We'll set our power supply in here and get that wired up. And then the only thing that'll be interesting is we'll still need to figure out something to do with the antenna. For right now, we'll probably just feed it through the side of the skirt when we put that on to keep it out of the way. Okay. And I'm not sure. I need to get some M2 by 10 self-tapping screws. And the M2s that they had in this kit, I think were just straight, I'll say like machine thread screws, not really the self-tapping type. So I'm going to grab some of my M2 by 10 self-tappers here, because they've got the, the pointed tips to them that makes them a lot easier to actually screw into plastic. I know it feels bad that I'm using the Trident over here. Got the Trident over here and I'm kind of using it as a shelf right now. But don't worry. We've got KB3D, Chris. I ordered some replacement panels through him because the panel kit I had gotten before was missing a panel, and they don't have any more. They're switching over from acrylic to PC, polycarbonate panels, and it's going to be like 2-month lead time to get those. So I went ahead and ordered another set of panels from Chris, and when they come in, we'll get that one all paneled up. And so we'll do a little, we'll have a cameo appearance of this Trident in the near future as we get it going. And then underneath the Trident in the big box down there is the LDO Boron 2.4 kit, with the purple frame that you've seen me post pictures on Twitter. And then the other thing that just arrived is an Ender 3 that will be the donor for the belt printer, which will be the next project that we start on Tuesday. So, yeah, no screwing around. Correct, Free Heathen. We got to stop screwing around. Let me grab my Phillips head screwdriver because these are Phillips head screws and not socket head cap screws. And it's just a matter of trying to get it lined up and get the screws started. Okay. These I'll have to get them started here. May have to use a different screwdriver to try and get them locked in. It is hard to get torque on a tiny Phillips head like this. So I'm going to try and get this in there, but yeah, Rob's the baby belt guy, but he's also, you're working on an IDEX, correct? May not have a good enough angle on that one, but if I can get a couple of 90 to see if I can't get these get better leverage on these and get them screwed in. So if you follow me on Twitter or if you're on my Discord, you would have seen the rest of wiring day yesterday, which I had spread all over my desk. What you didn't see was the mess that was also all over this workbench. And this 2-foot square platform right here that I move my laptop over to when I'm doing streaming. This had stuff all over as well. So that's another reason why I don't tend to wire on stream, is when I start doing wiring and I'm trying to make everything pretty and routed nice, it just gets messy. Like this wire, I should really shorten up, but I'm not going to, because I don't want to recrimp things. And once again, we'll hang this out the side of our skirt, which will mount here. And then our power supply, it gets mounted on this side. So we have 2 screw holes on this side, 1 on this side. It's made to be able to work with a couple of different types of power supplies. But we're basically going to use this hole and one of these 2 holes to get there. So we can, I am hoping that I can get the holes to line up this direction. And if not, then we're going to need to mount it in this direction, which I don't necessarily like, but we would have to run our wires clean over here. Doable, but I'm going to see if I can do it the other way. And also, always make sure that you're flipped to the right voltage on your power supply. So what I'm going to do is rotate this 90 degrees so that I can see my holes and see if I can get things to line up the way I would like them to. Because once again, I'd really like it to be able to mount like this. Can't see. I can tell that I can get one hole at the top. I just can't see if I can get one of the holes at the bottom to line up. There's a top hole. And it's oh so close, but won't line up in this orientation, which means it needs to be mounted in this orientation. What am I catching on? This is on wires. Well, that doesn't line up either. We're going to have to figure out how to make it fit this way. I mean, it's close, but it doesn't line up 100%. It's not lining up 100% because I think it's hitting this screw right here. And that's what's keeping this edge from coming all the way up. So I need to pull this screw and see about replacing it. It just comes out just a tad bit. if I kind of pull it in flush, yeah, it gets a little bit loose. So let me, yeah. Let me see. M5 by 16. Let me see if I've got an M5 by 14. That'll get me. Yeah, yeah, we definitely, it cannot stick past um the nut, but you're gonna have to have a um like an M5 by 14 would be the best because that'll get you your um 2 millimeters back. And I've got a button head. I probably have a 14 socket head, but we're just going to use the button head. I'm going to see if I can't pull this nut in a little bit more as well. There we go. So the nut's fully seated. All right. Thanks for the lurk, zombie. Yeah, socket head cap screws. Gotta love them. And that ought to work. So I'll put that back over there. Your power supplies, the mounting holes are always M4, so they did supply some M4 by 12s, which I think as button heads are going to use the 2.5, which they do. And it needs to go into this side here because the other side doesn't have mounting holes. And yeah, we were going like this, right? Or no, we had to go the other way. Let me see it. Lined up there. And we get a hole lined up there. Awesome. So that was the issue, was just having a wire in the way. So what we need to do is we'll connect our wire to our power supply here. So we don't need this full length. So I'll probably say just kind of cut it in half, strip this end, put the spade connectors on it, and that way I can use this for future test bed stuff. So let me grab my snips and my wire strippers. Yeah, these do make good benchtop uh, power supplies if you're going to be trying to test out some boards. So definitely worth having. Okay, it looks like OBS just decided to do a reset on me, so hopefully everybody's still with me. And as noted before, we're using white hot and blue cold. So blue would be the negative or neutral, and white being the hot or live wire. And you'll notice I try and keep this closed when I'm not actively using it. It's because I've spilled this once before, and you'll learn. Same thing with all my other screw and fastener stuff, because the one time you don't close it is the one time you're going to hit it and knock it over, and then you're sorting things out. So once again, just to double triple check, we'll take our diagram and we'll just validate. Yep, ground. So we'll put it in the same orientation. So our ground is over here, the farthest away, which is our blue. The 24 volt or 12 volt is the white. So now that we validated, we can go ahead and connect our negative and positives. Really need my other screwdriver. One positive, one negative. Okay. And then we'll work this wire just to keep it out of the way. We're going to just nicely fold over this UART wiring and slip our piece in there. It'll be easier to start with one up here. Oh. Okay, why are these not going in? Are these Well, I'll be snookered. Normally all your power supplies are M4 screws, but these may be M3 screws. Like I didn't even try M3s because they're normally M4s. Ah, I'll be snookered. They're M3s. Okay, so we're going to have a couple of M3 by 10s. And we'll try this again. Tens aren't going to have enough bite to them, so we'll do 12s. You really don't want really long screws when you're going into a power supply because it would be very, very bad if you run a screw in and connect to something on the inside. It could be an electrifying experience. Yep, kind of shocking, you might say. Why is that not lining up? Unfit your gang. There we go. You just had to get the right angle. So now we've got our power supply installed. We've got our Raspberry Pi, Banana Pi installed. We're going to go ahead and put a skirt or two on here. These should go on with M3 by 8 screws. And they'll go right into our heat set inserts. And I will route the antenna through the side here, like I said. That way it would be laying out kind of hopefully away from the power supply some. Your front skirt does have the Rook logo, and I need to try and figure out how to color it so that it shows just those pieces. And that's going to be awesome because putting this on covers that. Ugh. Why? Why does it have to be difficult? Apparently, I've got to put the skirt on first, then I can mount the power supply. Now, let's see if we can get our power supply to line back up. Just like that, we've got one more skirt over on this side. Use a ball head driver on that side. I get the feeling I'm cross-threading that, but then we're done there. Now what I'm going to do is tighten my belt on the Z-axis. It doesn't need to be super tight, just we're going to apply a little bit of rearward pressure on the motor. Just to snug that belt up a little bit more. We'll just tuck those in. Like I said, we will need to add a fan in here, so I'll get in there a little bit later and add that fan. But for now, we should be good. That box out of the way. And we'll figure out something for our, little clip or something for our antenna. I think my screws over there may have pressed into the bottom of the piece there. Get that out of the way. Get these couple of things out of the way. Put some things up. Meanwhile, we're going to unplug from the back of our brick. And we're going to plug into our switch in the back here. Which for some reason does not want to oh really? Those the So the side clips on the piece that are supposed to go down and then clip in to hold your switch in place are not engaging. And because of that, it's preventing the plug from going in, right? So we'll have to, we might have to, ooh, did that, I think that just clipped. Okay, so we're going to go ahead and hit the switch. And if everything goes right, no smoky, I am getting lights on everything. So we will set her back up here. Let her get started up while I put away some screwdrivers. We'll go through and update the punch down list. So we mounted the Banana Pi Zero. We mounted the PSU. We've installed the skirts. We still need to install our Bowden tube. So in order to install our Bowden tube in our hot end, we're going to need to take off the rookery shroud. And the shroud should just be able to slide forward. And we can just hang it off to the side for a moment. Because what we need to do is take our retaining clip off. So we can set our Bowden tube in there. What do I do with the Bowden tube? And they give you plenty of Bowden tube. So you're just going to take that, push it all the way down in there, which it doesn't go very far. And then you need to put your retaining clip back in. And then we will work our rookery back in place. And of course, we have to remove our, we don't have to. If I just route this through there, it'd be easier. Hey, Chris, how are you doing today? Hope you are doing well. We are in the final stages of our Fabreeko Rook build here. Just trying to get our bowden tube installed because I didn't do it beforehand and didn't think about it. Our bowden tube's in there. Now we're going to shut the motors off so I can move this out of the way to give myself some room. The wires on the CHT are kind of a tight fit around the shroud, so that's what I'm kind of playing with right here, is to get those wires in place within the shroud. There we go. Fantastic natural caffeinated. Exactly. So for those of you that are just now joining in, caffeine is the lifeblood today. I was up until 3 a.m. working on this printer. Apparently I need my other. Mechanically, it was all good. I got the wiring done yesterday afternoon for the most part and got everything cleaned up. It was more of trying to get the banana pie set up, right? Exactly. So my wife was nice enough to bring me my morning Dunkin'. Guess it helps if I get the sticker off of it. There we go. So she got me my morning Dunkin'. So Dunkin' Donuts, if you're anybody here works for Dunkin' Donuts and they feel like sponsoring me, you know, we have a standing order for Dunkin' on stream days for large coffee and a set of munchkins. So our bowden tube, we're just going to kind of figure out where we need it. And we will cut this and get it put in place. Where's my cut guide? The sharp blade, you know, the one that I cut myself with the other day. We'll just cut that. Probably should chamfer it, but I'm not going to take that back out to chamfer the other side, so we're just going to roll with it. And this is just a press fit in there for right now. I am most likely going to reprint my Sherpa Mini parts for two things. One, hey Subsector, how are you doing? Thank you for the continued subscription for 4 months. That is so awesome. Thank you. So on the Sherpa Mini, what I'm considering doing is, one, I'm going to reprint the parts so that I can use I think this one might go in it now. This is an ECAS fitting, but I have a different type of fitting, and there's a printed part that you can use that will let you use one of the compression fittings so that your tube doesn't come out when you're doing retracts and stuff. And yeah, that's not going to go in there. So it's just a matter of printing out a different front housing. And what I'm going to do is actually print out one of these styles. So what you see here, this one allows it's got a groove in it that will allow a press fit compression fitting to go in the top here, which will provide a better connection point for your PTFE tube. Or I'll use this one, which will let you use a screw-in compression fitting at the top. Both of these, though, you'll notice that there's a longer piece here that has some holes in it. This will allow you to actually mount a end stop on it, and using a second screw through the top, it acts as the plunger for your end stop, and it's a very cheap filament runout sensor. So that was what I'll do, is I'll set that up and I'll add another wire that I'll just bring down into the loom, and I'll use the E0 end stop connector, which is actually the filament runout sensor on an SKR mini board. Hey Photosment, how are you doing today? I'm doing pretty good. Like I said, I was up till 3 working on this. And then solved it this morning, and the gist of it was, the issue I was having was I couldn't get the banana pie board or the Radza Zero board to connect to the SKR Mini via UART, which was throwing me nuts. It's not necessarily an ERCFA filament sensor. It will work with anything. I've actually got one installed right now on the Ender 3 back here in the corner, and it works great as a filament runout sensor because it's right at the top of the tool head and it's right before the gears. So yeah, it just works. But we are now fully set up. We've got our bowden tube initially installed. Once I reprint the Sherpa, it's just everything right here. I'll take this apart, rebuild it, mount it back up, and I'll have that compression fitting that I can just put the tube in. So I won't have to change anything else on the printer in order to do that. If I do go through and put the runout sensor, I'll just have to run the wire down and into the loom and attach it to the board. So I'll have to take some stuff apart to do that. Yeah, it could work with a ERCFA. It could work with a trad rack. Any of your multi-material units, you can use it for. Now, an ERCFA or something on a printer this small, maybe. Not sure if it would be that worthwhile, but it is worthwhile. And we're not going to reprint the Sherpa Mini today, which means the next thing on the punch down list is pushing plastic. Yeah. So I'm just going to slide this forward some, give us some slack. Let me straighten up a couple of things back here so I don't, yeah, that's okay. It's okay. This is here. This is going to get moved to the side so it's out of the way. And I don't have a build plate on here. I do have a nice Honey Badger build plate, but as you can see, I have a few build plates for V0, and a lot of these are double-sided textured LDO plates, but one of them has some battle scars. Guess which one we're going to put on this as we do our first test? Because I really, really don't want to mess up a brand new Honey Badger bed on a first run. And with that, we're just going to grab a spool holder and let's pick a open spool of filament that is at least PLA. We're going to grab something that's got a K2 clip on it because, well, why not? And this has been sitting out in the shop, so it may be a little brittle. We shall see. And normally what I do here is put a little length of PTFE tube at the bottom of this so it makes loading it easier. Oh, got a heck of a bulbous end on it, so that's why it's not going in. Okay. I almost feel like I've got... We did clean this out with a drill bit earlier, didn't we? Almost feels like there's a burr or something in there. Here, there, I've got it way too tight. There we go. I may have just had it way too tight. Yay. Now, I also have not, I haven't checked the direction, the rotation direction on the extruder yet, and I haven't calibrated E-steps. So what I can do, though, is I can look at one of my other printers that is running a mini Sherpa and kind of just grab that as a good starting point, which is something I will do real fast. Because I don't think, yeah, I'm not running one on that one. So let me jump over to baby blue real fast, which is my boron B0. And I'm just going to take the initial rotation distance from the extruder. So here, let me show you guys what we're doing. So I came down here to the extruder and we've got a rotation distance and a gear setting here that I will use. The one thing you've got to be careful of is the motors, these spur gear motors for your orbiters, your Sherpa Mini, etc. They could have either 8-tooth or 10-tooth gears. So you need to be cognizant of that. And I'm just going to take this rotation distance for the time being and comment it out. So there's two ways of doing it. You can put in your gear ratio and then figure out your rotation distance, or you can basically run the extrude test and update your rotation distance without identifying a gear ratio. We'll say 6 one, half dozen the other. Now the standard test that we're going to do is we're going to mark 120 millimeters on our filament, and then we're going to tell it to extrude 100 millimeters, and then we'll measure how much is left. And the way I do that, and because it's all relative, on my ruler, it starts off right at the end with the measurement. Even if there's a gap, like on some rulers, don't worry about it. Take your piece of tape, line it up at 120. Wow, that is just not, here we go. Take your tape, line it up with 120, and then you're going to measure from the end of your filament as it goes into your extruder. And in this case, I'm going to have to lay the printer down to be able to get to it in a good line. So we'll lay the printer down. No harm, no foul here. And we're going to put this right up against the bottom of the extruder. And we're just going to line it up to 120. And then we'll pull the tape onto our filament, right? You don't want to try and wrap it up into itself because you might have to do this 2 or 3 times. Okay, now we've got our point identified. So we'll come over here. We have to have our hot end temperature up some. So we'll tell it to heat up. Let's tell it to go to 190. And our fan did just kick on. And once we get up to speed, you notice we're not going through a bowden tube. We're not trying to push through the hot end. We're just trying to see, one, that the direction is in the right way, and 2, that we've got the correct number of steps. Thank you, subsector. And you can see how tight this coil is. This is, once again, it's been sitting out in the air, and it would probably do well with a running a drying session on it. But we're now up to temp. Our hot end's up to temp, and I believe we've got it set to 170 where it has to be or it will not extrude. You can change that to do this testing, but it's just easier just to heat up the hot end. And then we're going to come down to our extruder section. We want to select 50, and they tell you to go 1 millimeter per second. I normally go 5 just because I don't want to wait, but you can go 2. And all you're trying to do here is get precision, right? So we'll go to 2. We're going to say extrude. Now the filament should go from the bottom out to the top if it's in the right direction. We still don't know. It is in the right direction, so we're good there. And I am seeing some skipping going on. The 1, I saw a lot of skipping, and 2, pretty close still. I am going to take and tighten our screw back up just a little bit, the tension screw. And we're going to tell it to extrude another 50, and it's going to run. Meanwhile, I'm going to hydrate a bit. Hey, Major Gamer Geek, how are you doing? Okay, and we're done. Now what we're going to do is we're going to measure, once again, from the bottom of our extruder to our tape line, and we're at 19 millimeters left. So we over extruded 1 millimeter, right? So what we'll do is we'll come in here to machine, printer. We'll come down to our extruder section. And our current E-steps, or in this case, rotation distance, is 22.23. So we'll grab our phone and bring up our calculator. Make sure we're cleared. We're going to put in 22.23. We're going to multiply it by how many or how many millimeters we actually went, which in this case was 101. So we'll multiply it by 101. And then we're going to divide that by 100, which is the number of millimeters we wanted it to go. So our new number would be 22.45. So we'll just change this to 0.45. We'll save and restart because we need to we need to save that setting. And then I'm going to remove my tape. And I'm going to put it back at the 120 mark. On my ruler, right? We got it right at 120. And we're going to do it again. Because what we want is consistency. So we'll line it up with the bottom of our extruder. And we'll put our tape over onto our filament. Okay. You can mark your filament as well, but I find using tape is just as easy. It gives you a better, more accurate line marking on the filament. So once again, we'll need to get our temperature back up. So we'll hit 190 and let it come back up to temperature. Right now you see that the controller fan should be on. I still haven't installed that controller fan. I'll have to remove the power supply, install the fan, no big deal. And once I get that installed, we'll then have air that'll be flowing right over the top. It'll be flowing in the channel between the power supply and the MCU. So, yeah, you know, I've tried to mark it with a fine tip Sharpie, and it's not going to impact a print having just that little bit of Sharpie on it. But I find using the blue tape is just as easy, and it's a little bit quicker. A little more accurate too, because you can line it up nicely on your ruler. Okay, so once again, we've got 50 millimeters for our length. We've got a 2 millimeter feed rate, and we're going to say extrude. And this will be our first 50 millimeters. Okay, and then we'll hit extrude again, which will get us our next 50 millimeters. Okay. And now we'll come in and we'll measure. Still a little, I'd still be a little bit over, so I'm about 18. Yeah, I'm at 18. But that makes sense because remember the first time when I ran the first 50 millimeters off on the first run, I think my tension was way too loose over here. So I was seeing a little bit of skipping. So I'm seeing 18 millimeters left. So I still went 102 that time, which does make sense because I'm not skipping anymore. So we'll redo that calculation. And that's why you double check and you don't just do the calculation once and go. You'll double check it. So we were at, it was 22.45. We're going to multiply it by 102. And then we're going to divide it by 100. And that would put us at 22.899. Anything past 2 to 3 decimal places, I mean, you're getting nitpicky. We're going to save and restart. Grab our heat real fast so it doesn't drop out. Mark our ruler again at 120. We'll mark our filament. And run our test again. Oh, hey, Shenanigans. Yes, I really like the color scheme, this printer. It's Polymaker Blue ASA and Lime Green. And it really came out really, really cool. So I really like the way it came out. The color scheme looks great. Once we get this calibration done here, we'll be able to flip it back up and actually push plastic through the hot end. We still need to do a PID tuning on the bed and the hot end. There's factory default settings in there now. Okay. Now let's go ahead and check this. I don't know if I'm off or what, but so it's showing 19, which meant I went 101. So take that last number, multiply it by 101, divide by 100, and we're back to 23.12. And all we're trying to set here is the mechanics of the extruder. once you get the mechanics of the extruder set, then that's when you can actually go through and do a lot of your tweaking on your extrusion multiplier and pressure advance and all that. And the other nice thing about doing this where you're just extruding into air is, well, one, you don't have to worry about, you're wasting filament because you can just pull it back through and run it in your print. Or two, if you've got a really long bowden tube, well, you need to fill the bowden tube up anyhow. Oh yeah, subsector, I can imagine. It hasn't been crazy hot here, but I do have my AC seems to be kicking on a lot more than normal. And of course, where it sits, it blows right down where my desk is. So I'll be sitting there in the middle of the day, and all of a sudden I just get a chill, and it's because that air is blowing right down on my back. Okay, now let's see. All right, we made it. That's good. So we are good. And we've got the mechanical calibration of our E-steps done. We have those saved. We validated that our calculation was right. Now what I'll do is I'll just pull this back so I can set this printer back up. We should be good to go to just push this through and into our hot end. Okay, so right there, it feels like it's in the hot end. Oh, oh, oh. We've got plastic. We're technically pushing plastic manually. Go ahead and increase the heat a little bit. And we're just going to go ahead and push plastic. Tell it to extrude 50 millimeters. And that's not going to work because our PTFE tube just raised up out of it. That's going to be the issue with the Bowden is you really need this top coming out of the extruder to be tied in, and it's not. Therefore, it just pushes the tube out, not really let's see if we can do that again. Still going to push that tube out of the top. So I don't know if I don't have a tight fit in there or what the deal is, so I'm going to have to fix that up here at the top one way or the other. So we may have to take our Sherpa apart today and work on getting this bowden tube down in there. Because it should be a press fit, but it does not appear to be, or at least it's not staying, and I don't want to try and like glue it or anything like that. Yeah, so it just keeps pushing the tube out of the top here. So I'm going to go ahead and pull it off. I kind of wonder, because I should be able to pull this tube up, and I'm not, which that's almost telling me that the bowden tube itself might be way too tight for this filament. And this feels like it's a Capricorn, the tighter tolerance Capricorn. So on a bowden tube, you want a little bit of tightness, but you don't want it to be way, way tight. I mean, the fact that I'm going to cut that, and I should be able to pull this out without anything, and I'm not. Let me heat this back up. Thanks for the alert, Chris. I'm going to heat this back up some, and we're going to try and pull this filament out. And so we're at 200 degrees. I should be able to pull this filament out through the bowden tube. And I'm not. I'm not able to get this out, which means this bowden tube may be way too tight for this particular filament. I'd have to find my calipers to see if this filament's in tolerance or out of tolerance. I have no idea what kind of filament it is. But if this is the tight tolerance Capricorn tube, then that could be causing us a problem. I mean, we're pretty close to 175. I just don't know why we're having an issue here. Because, like I said, I should be able to pull this out, and I'm literally picking the printer up. So we're going to have to do a couple of things here. I'm going to take my shroud off because I'm going to need to take my bowden tube out, which means, hey, Ipaku, thank you for the lurk. So I'm just going to move things around just a little bit. I'm going to pull the shroud off. So I can undo my clip and pull my bowden tube out. Preferably without touching my fingers. And that's actually I think that's causing the problem right there. That got caught up just going into the hot end. So this hot end's going to start getting a little hotter than I want it to, but hey, Creatix Brit. We are manually pushing plastic because I'm trying to figure out what's going on. I had filament that just did not want to work right. And I'm not sure why it's not aligning properly. You're going to do that again, aren't you? Yes, I am trying to diagnose an issue with a hot end that's still hot and a cooling shroud that's running, which means I'm plugged in. Things you should not be doing and teaching people on a live stream because things can go wrong. So yeah, I'm not sure why our filament was getting borked in this hot end. Once again, we're using the hot end. It's a CHT style hot end, which means it's a ceramic heater core style hot end. Similar in some aspects to a Revo hot end, but not. And I'm not sure why I'm getting a weird, I'm not sure why this isn't aligning up all that great. But I'm not sure why I'm getting a weird filament head on it trying to go in. So we will try this again, and what I'm going to do is just pull the filament out, make sure I have a decent tip, and we're just going to manually run it. So I just got to the hot end. I think I just got through the breach in the hot end, and yeah, this is an issue with the filament getting into the hot end. And that just got stuck again. So this is a mechanical issue at the hot end. So I'm going to go ahead and cool the hot end down. We're going to unplug it. We're going to take the shroud off. And we need to try and figure out what's going on between the PTFE tube and the internals of the hot end. And for those that may be interested or may want to know, the part cooling fans, which are these two blower fans on either side, I cut the connectors off and then wired both positives and both negatives together with a long run that goes all the way back. And the hot end cooling fan here in the front, I snipped that connector off and just made a long run that went all the way back to the board. And our cooling fans are working for those that are interested. Oh yeah, this is an awesome size. It worked great for like the table at Midwest Rep Rap Fest. Or at least until the external brick power supply gave up the ghost. I'm just going to let this cool down a little bit more until that fan turns off, and then we'll take the top end apart again. So this is a standard B0 bed, so roughly 120 by 120. I believe I've got it set at like 115 by 112 is kind of the limits because of the shroud. But yeah, it's a pretty decent little printer. Okay, so we're back down to like 40C at the hot end, so I think that's kind of good. We are going to take this front shroud off again. And try and figure out why we're getting a hang up at the Bowden tube. Because mechanically, that's what it feels like, is it's hanging up at the, oof. This motor's way super hot, so we'll have to, I'm gonna have to check this. That may have way too much current going to it. So we're gonna pop our shroud off once more. Put it to the side. We're going to take our clip out so we can pull our bowden tube out. And once again, there's the tip of our filament, and it's not, we're getting a weird, goodness gracious. We're getting a weird wonkiness on the tip. So I'm not sure if it's that the bowden tube isn't getting seated all the way down in there, or if it's a different issue. I've never used this type of hotend, so I don't know how far the bowden tube is supposed to go in there. I mean, I see the mechanical connector, but we're almost seeing like it's doing a jog. So let me take this one and see if I can't. I mean, yeah, that's as far down as it goes, and I am pushing pretty darn hard. So we grab a Sharpie so I can mark that. Yeah, I mean, that's going in there like, what is that, 11 millimeters? So Fotis, this is I believe it's a $299 kit. So it's like $300 kit. I have a feeling like that's sticking up because it's hitting the, yeah, it's the screws from the Raspberry Pi or the Banana Pi. So we may just cut those off to make it easier. So we're going in like 11 millimeters, and it's giving us issues. Like I said, I've never used one of these before, these hotend types before. It's definitely down all the way in there, but it's doing this weird jog right at the top, and I'm not sure. I mean, I'm not seeing anything in there. I was able to push the filament all the way through manually without the bowden tube. You know, I'm not seeing an obstruction. You got to loosen the heat brake and push it back up because of how it's tapered, the heat brake. So I'd have to take this apart, loosen it, and then push this back up. I mean, it looks like it's all the way up there, but we'll double check that, Chewy. So I just loosened that. And it doesn't really look like it went up or down an appreciable amount. Trying to look at the so once again, this doesn't go but more than a couple of millimeters. So, and then you hit the throat, which you can't change because that's the throat that's in here. And then this actually goes around that throat and bottoms out. And my issue that I'm having is right up here at the transition from the PTFE tube into the throat itself. Let me grab a shorter piece of PTFE tube. You'll see where I'm going in a second. So I put that in there. Now I'm going to take my plastic plow, which is like 1.75 rod, and it should go straight through, but I'm still ever so slightly catching. Like I feel just a little bit of resistance. It's not a whole lot, but it's just a little bit. And this thing is scorching, so give me 1 second. I need to, wow. What is my current on this? Oh, oofta. Somehow I don't think that's right. We'll have to double check that, but for right now, I need that current, I need that to chill out some. Yeah, and that's where I'm thinking is it's that lip between the bowden and the throat that's catching and causing that weird jog like that. Oh no. I've turned the power back off. It's cool. I mean this motor's a little hot. I don't know why, but and we're gonna pick a different spool of filament because this is gonna drive me crazy. This is a gray PLA, and I literally have like no idea what brand it is. I'm assuming it's probably like a Sunlu. We'll grab our Zyltech or Zyltech. What I want to do is just run it manually through the tube. Yeah, see right there, it's catching. You know, it's not a PTFE, it's the PTFE to the throat. And you can't guarantee, I mean, this has a straight tip on it, but you can't guarantee that you're going to have a, I'll say a well-formed tip. So the fact that it's catching ever so slightly there, and my heat break's completely out. This is all internal to this piece. So there is nothing I can do about the machining of this piece. Ah, pull the hot end off. There's two tiny screws in the bottom that'll hold that throat in. Right, so that's just the heating element. Yeah, Timur, that was on my mind of do I need to ream something out here or not? Um, I should not have to on a brand new hot end, but that thought did cross my mind. Um, you keep that from unraveling. Find the grub screw that just popped off before. Tiny, tiny black grub screw on a black tabletop. So, which screws do I need? Because there's no screws there. Use a hammer. Yeah, use a hammer. That'll fix it. Um, yeah, like I said, it's just weird. And it's the transition point of where the PTFE tube goes in because I put PTFE tube in and I should, yep, still see all the way through it. And I should be able to take a piece of filament and run it straight through, and it's catching on a lip there. See, I just pushed it through with a lot of force and I get it past that lip. So my thoughtful question, this is a completely different hot end secure style. I really, really don't want to swap it. And if I do, I'm going to swap it for, I've got an ender, or an ender. I have a Revo CR sitting in the closet that was destined for the belt printer build. Because, yeah, this is a heat break issue. And I don't have Yeah. The problem is I don't have a 1.75. The only thing I have to ream with is a 2, which means this throat will be oversized going into the um, the nozzle down here, which means I'm just moving the problem further down. Okay, so what to do? What to do? Undo our wrap a bit. We're going to take a look at our thermistor connectors here. And as long as they've used standard connectors, I mean, I haven't had an issue with the Revo yet. And that should be able to work. Because I want to see this thing pushing plastic today. That is the goal. And then we'll start building we'll work on the belt printer afterwards. So what I should be able to do is just unclip that. Of course, forgetting that I am still powered on here, so I should probably solve that problem before I blow something on the board. So we pulled our connector. We will put that back in. So it is out of the way. And I will talk with Hector and Fabreeko about that. I'm sure we can get something squared away. And we will just need to route these up and through. So that one goes there. This one will go here. To get our PTFE tube routed in here as well. And then into, whoops, PTFE tube in here routed into our hot end. Yeah, use some abrasive filaments for the first 100 or so prints. Yeah, that'll work. And what I might do is see if I could get my hands on a 1.75 reamer. Because like I said, if I use a 2, it will it'll just exacerbate the issue because it'll just move it further down the channel. Okay, so do that over on the side, not right in front of the fan. Gentle bend. Gentle bend. There we go. So that's the nice thing, that at least they're using microfit connectors so that it's fairly interchangeable. I'll have to modify a couple of settings probably because I just switched over to the CR Revo, which uses the standard Creality thermistor. So that is the one thing. If you go to a CR Revo, it does have a different thermistor than the regular Revos. And looking at this, it looks like these wires are a little bit shorter because you can see I've got a bunch here now. But we'll try and get all this into the cable wrap. Get it covered up some. We'll have to figure out that piece a little bit later. You may just have an ugly looking top hat for a couple of minutes. All right, we're good with that. And I think the other issue that I'm having is the Revo actually sits a little bit lower. So I probably have to print a different rookery because the fins, the cooling fins, are going right into the side of the Revo. And if I remember right, I had to do that on Golden Dragon. So we can fix that though. That's an easier fix down the road. Having a a bad filament path, that's kind of a hard thing to fix without, as we were talking about, a reamer or something of that sort to work with. So we will try and work on getting that done. So we've got that on there. We've got it connected back in. We're going to turn it back on. And actually, before we put filament back in it, let's at least get the bed adjusted. And like I said, I'll have to print a new one of these. It's just one that's just a little bit longer because you'll see, I'll pull you guys in real fast. You'll see that the cooling here is aimed right at the nozzle. So it's not going to cool appropriately, but we'll make do for right now. it's just going to hit the side of the nozzle and flow downward. So. And then I'll get another rook shroud. I'll get the right rook shroud going for this, which will help with that cooling. It's just one that'll be a little bit longer. Yeah, I mean, I might have to PID tune, but that's no big deal. I mean, that's something we should be doing anyhow, is PID tuning. And like I said, I'll have to work on this and pull in some wires back. The issue right now is this sits a little bit lower than that other one did. So, and my goal right now is I just want to push plastic. Like that was the goal. We were going to push plastic, right? So let's actually come back over to our web browser, and we're back up and running. I wanted to, this one. I wanted to come back over here to our initial startup, and we need to get our bed leveled, right? And that we may have to do some adjustments here as well, because our nozzle just basically moved a little bit lower. So we've done this. It's moving in the right direction. We've got it homing. All of our sensorless homing and switches are working. I did the bed locating to find the 0, point, or validated the 0, point. Yeah, so this is where we need to check. So because the Z in stop is all the way at the bottom, we need to run the Z in stop calibrate routine to figure out how close we are to the nozzle. Oh, no worries, subsector. Definitely get some stuff done. Yeah, like I said, if I can get that other I really want to get the other hot end working. And like I said, I'll provide some feedback to Hector and them at Fabreeko and kind of show them what it was doing to the tips. Because yeah, that is just a slight offset, and as it's trying to push, it causes that break there, and it's not going to function right. You want a straight, clean filament path. And so I'll have to take some pictures of that and show it to Hector and them and see if they can't get me a new in-stop heat break or something, or see if I can't locate one somewhere. So we need to run this Z in-stop calibrate. And what that's going to let us do is set the right Z height for where our end stop is. So I believe what we need to do is start off by doing a homing event. Do this test with your nozzle cold. When it's heated, its position relative to the bed changes due to the thermal expansion. It's typically around 100 microns, which is about the same thickness as a typical sheet of paper. That's why we're doing it cold, and we will use a piece of paper. Yeah, so I'm just going to lift that up just a tad. I'm going to tell it to home. Get ready to do a Z end stop calibrate. And what I tend to use for these is a Post-it note. And not just any Post-it note, mind you. I use the Chris's Basement specifically calibrated Post-it notes. We're just going to stick that there, and we're going to paste in the command for the Z end stop calibrate. And you see me do something similar on printers that have a probe. And that's where instead of Z end stop calibrate, you'll do a probe calibrate command. And so it comes up and it says, okay, you say you're at 100. So let's, we'll kind of see if we, well, that was interesting. I'm at positive 100. You want to go. All righty. This is apparently going to take a bit. And I should actually be right in the middle, so I'm going to abort this. Do a home again. Yeah, no. So I'm gonna make it easy on myself. You just need to home everything. Then I'm going to do a G1. G1 for move. X. We'll say public math. 55. Y. 55. Z. 10. And that's going to move my head to the middle and the bed to a nominal 10 millimeters, right? That way, when I go to run my my ZN stock calibrate again, I'm not starting off at the very bottom and having to move up one at a time. So I just folded over the sticky edge so that I can slide this easier. And I just want that the end underneath the nozzle. And then we're going to do our ZN stop calibrate. It should pick up the current position, which is negative 10, or I'm sorry, positive 10. So we're going to start dropping it down. And we're going to be going into the negative. I don't know if I've got enough. -1, I just felt that on the paper. So that's pretty much no movement. It's a little bit of movement. So I think that's close, and we can do a rough. I'm going to drop it one more. Yeah, we're going to accept it right there. we'll have to do a save config to save that config. And of course, the bed drops all the way down because we dropped power to the motor. And then it throws an error because it did update the position in stop, but it's outside of the min and max position. So we go back into our printer config. Whoops. And for the Z, let's see where we're set. Our max position was set at 100, and our position min was to negative 1.5. Okay, so that means that we were out of bounds, basically. So we were set to 101.075 is where we were at. So there's a couple of ways that we can do this. And the easiest way is to give ourselves room to move. So we say our position max is 100, but our end stop is 101.75. So negative 1.075. If I take this and change it to negative 2.5, save and restart, it should come back up. Or maybe not. Fine. So it really wants my max to be higher, I guess. There we go. So we're at 101. So if we go and say that this is at 102, okay, now we're back up. Now I'm going to go through and do that again. And you see how my Y didn't go all the way back. That would be an issue. So I'm not sure why. I'm going to clear my motors and move things to the front again. Now my wires are a little tight. Okay, so we did that. We're going to run our G1, X55, Y55, Z10 command again to get close again. Then we'll run our ZN stop calibrate, and we will start getting close again. Okay, starting to hit the paper. Yep, we'll accept. We'll save config, that'll drop back down. And now let's take a look at what it did with our printer config. We're going to go all the way to the bottom. And the position end stop is now read at 1 101.250. So, okay, we're good to go there. Now we changed our settings. So I'm just going to home all again. And let's go to what the next step would be. Well, we don't have an inductive probe, so we don't need to deal with that. PID tuning the bed and the hot end. Okay, so we're going to start with PID tuning the bed. Now, this is set. This command that they've got set up here is a target of 100. You would use 100 bed if you were doing ABS. While everything on here is printed in ABS, and I can print ABS with this if I wanted to, theoretically, this is a PLA or a PETG printer. So I'm just going to change the target temp to 65, and we'll get going. Now, it's going to start PID tuning that bed, and we'll see how quickly this ramps up here. And Chris, Chris, if you're still here with us, it's probably a good thing then that the order hasn't shipped yet, because I might have you throw something else in the order, or at least in the shipment. I'll have to order a couple other things, and I'm kind of surprised it's going so slow. And while this is running, I want to check something real fast. Because I'm curious, it may be going slow just because I've got some settings wrong for that bed. So I want to try and find the bed real fast. It's a 100-watt polyimide heater. Up to spec, doing its thing. Meanwhile, I want to come in here and take a quick gander at the config for the heat bed. Okay, so that is the right thermistor type. Sensor pin, heater pin are correct. Min temp, max temp, PWM cycle time. The PWM cycle time helps out to keep your lights from flickering, by the way. Yeah, I just wanted to make sure I didn't have a config in there that was limiting the power that it could push. But that looks right. Hopefully this will fix some of the PID and the ramp up time. Because I'd really expect it to be able to ramp up a lot quicker than that. So Chewy, what are you working on today? Anything interesting? Still printing Trident parts? Yeah, I need to start printing parts for the Voron 2.4 build. I've got the color scheme. I just need to start getting it built. Or not built, printed. Uh, yeah, it's got a few more parts to it because of the 4 motors for the flying gantry. Yeah, I think the part count is a little bit more because of it. And it's an LDO kit, so there's a couple of parts that are different. And you've really got to kind of go through and decipher, okay, which parts do I need to print from the Voron repository and which parts do I need to print from the LDO stuff. So, and I've also got I think it's 3 parts that I need to print for the belt printer, which will be what we're going to start after this is pushing plastic. Yeah, the belt printer will be up next. We're going to use the Ender 3 that I just got in as the quote unquote donor for it. And yeah. I mean, quite honestly, I can work on building this while we're sitting here waiting. because this may be an alternative that we can put on here as well, or we can put this on the other rook. This is a standard CHT nozzle, and I also have we've got a standard CHC and an upgrade that would basically make one of these a volcano style. Oofta. Hey, Westery, how are you doing today, sis? Hope you are doing well. Here I thought I had everything squared away and ready to go, and we were just going to push plastic and be printing today. And we've taken the printer apart a couple times. So we were having some issues with the filament path, and I'll show you kind of what we were running into. So using the stock nozzle here, so using the stock hot end, right? You got PTFE tube. PTFE tube goes into the hot end. It gets shoved in there. It's all the way down in there, right? Then you take filament, and let me just cut off a chunk of filament here. And that filament should be able to go through that path and down to the nozzle, right? So we start putting in that filament. And did you see right there? There's a ledge. Now, right where I hit that ledge, there's only that much filament. There is no way that's down to the nozzle. So it's hitting a ledge where it goes from the PTFE tube to the internal throat here. So that throat is not an appropriate size, and you can see that it just hit right there, but if I push hard enough and give it a little twist, it pops past it. Now I'm further down in there, and I'm down into the nozzle. And what's happening is my filament is getting kinked like this, and it's not extruding. So I need to take these things and show it to whatchamacallit, Fabreeko, because they may have some poorly machined hot ends that are going out in these Rook kits. So right now what I did was I put a Revo CR on it, which is what I'm running on Gold Dragon, which is my other Rook that I had at Murph with me. And one of the issues we have there is the Creality CR is a little bit longer. So I need to reprint this shroud if I'm going to keep it. And what I'm doing here is I'm putting together another type of hot end that I had purchased, and I'm just going to try and see from mounting holes if this is the same height, and this is a lot closer in height. So we may put this together and actually use this instead of well, I'd have to at least re-terminate this end into a microfit to be able to do it. But we may wind up using this instead while I go back and talk with Fabreeko about, hey, we need to fix this. So how are you doing today, Westry? Okay, so that would be for the JST. That's it. I might have to redo wiring if I put this in place, but I'm cool with that. You're doing good? Sweet. So right now you kind of see a little bit of a jumbled mess up here, and that's because the CR sits a little bit lower, the wires for the actual CRs, they're still microfits, but they're a different, I want to say they're a different length, but they sit lower. So I've got some extra bunch here. It's messing up my, my Zen, because I had all of the wiring done so pretty. And we finished some wiring this morning. I finally got the banana pie working this morning. Yay! And talking with the SKR Mini E3V3 underneath here. Yeah, the aesthetic. This is messing. It's just messing up my OCD here. Good gracious, this is a long pig calibrate. I don't ever remember it taking so long. But looking at our graph here, you'll see initially it was a higher spike, then a little bit lower, and these spikes are getting a little bit lower. So that's good. So it's heating up and cooling off a lot quicker, and they're getting better at the heat up. So, hey, Pezliz, how are you doing? How long have you been lurking around? So, meanwhile, I've been playing around with building a new hot end. The only difference is this uses a JST. I can either cut that off and put a microfit on it, and I should be able to do a drop-in replacement for the Rook one. Sorry about that, folks. So if I can get the Rook replaced, great. The hot end from Fabreeko replaced, great. If I can find a 1.75 millimeter reamer where I can ream that channel out, that may be useful as well. So a couple of things that we might be able to work on there to try and get this switched over and recover my Creality CR, my Revo CR hot end, because that is destined to go in the belt printer, which is what we'll be printing on building next. Good gracious. Even this one's got that same like ridge happening. I wonder if these require a chamfered PTFE tube. And do I have a like E3D chamfered tube? I mean, the answer is yes. It's just, where do I go to find it? And I haven't seen Modlite here. I do owe Modlite a package, so I need to get that stuff going. So that could be it, that it requires a chamfered PTFE piece, and it just doesn't mention anything in the instructions. There we go. And when I say chamfered, so I'm not sure if this will show up well. So our PID parameters, or our PID tune, just finished. So we'll do a save config, and like I said, you'll notice these heating blips here. Those little mountains got a lot smaller as we came to the end here. So we're going to do a save config, which will do a reset of the board and save those new config settings. And I'm just going to validate. So PID KP was 65.652. We'll come to our printer config, and we're going to scroll all the way down to the bottom. And we should see the heater bed 65.652. So it did update the heater bed PID information. So next up, we're going to do the same thing, but we're going to do it for the extruder, or the hot end. So we'll PID tune this. And I'm fine with it going to 245, because if you print PETG, you might be up there as well. So now we're going to PID tune this. But what I wanted to show you all is, when I was talking about a chamfered end, this is what I mean, where the PTFE tube has a slight chamfer on the exterior edge. And these are normally required for your E3D V6 hot ends for your Prusas. So I'm wondering if I put this in here, if that's going to help with that guide a bit. And if it does, then that's going to be that may be the resolution that we need to deal with. Okay, there's still a little bit, but there's nothing like it was. So that could very well be it, is it needs a chamfered end, and I didn't give it a chamfered end. And so it was able to kick off to the side just ever so slightly, because once again, our filament is kind of twisted. It's not a straight in and out. So now I put that same chamfered tube in here, and let me see if this goes in and out a lot easier. No, see, that still hits there, right? So that's still hitting. So the chamfered tube is not making a difference here. I still have to push really, really hard to get it over that edge. So yeah, I'm just going to chalk it up as this as being a poorly drilled hot end. Yeah. No. Well, I have gotten filament through this by manually pushing it through without the Bowden tube being in place. Whenever the Bowden tube's in place, there is a slight ridge as you transition from the Bowden tube into the all metal throat in this piece. So really it's just I need a different cool side that's got the appropriate like I don't know, it may be off center. For all I know, it may be off center. And I don't want to drill this out to a 2mm, because if I drill the heat break out in this to 2mm, then it's oversized and I could get other issues and a lot of jams in here. So if anything, I want to make sure and run a reamer that's 1.75 through it, but it's going to be an issue. So like I said, I may be able to swap it out for this one, and you'll notice how long these wires are and then how long these wires are. So the issue is going to always be this right here being way longer. So I'm going to have to redo my wiring because I made my wiring just fit. So I'll have to replace the wiring if I do a swap out for this versus the other. And if I can run screws through there, so the screws are kind of lining up, you'll see that the hot end's just ever so slightly a little bit further down, but this should still work with the current shroud. Maybe. Yeah, maybe not. Yeah, I don't know. I'm gonna have to figure something out. Yeah, it's QC on the manufacturing side on that. So I need to see if I can find the screw that I just dropped and see if I can get a new heat sink for that. Oh, wow. I have no idea where that screw went. But I think the carpet ate it. So Okay, and I just heard the fan go off, so our PID tune for the hot end is done. So 33.531, we'll go ahead and do a save config. I'll take my chamfered tube and put it back in here. Yeah, so we're gonna have to figure something else out. So this one sort of possibly maybe works, but I'm gonna have to redo some wiring. This one should work no problem because, well, it's a Revo. It should just work no problem. But then I would have to print a new shroud, fix a little bit of wiring, which is not that big of a deal. And I really wanted this to, to be, what is that? So darn tight to get through there. I really wanted this to be the fully stock build. Goodness gracious. Yeah. Sorry, my brain's going off here. I'm thinking I've got a burr in the filament path back here. Thought we ran screwdriver through here, or drill bit through here during the build. If that doesn't help, it doesn't help. For whatever reason, it's another tight filament path. Yeah, this is messing with my karma and everything else. Just messes with me. Okay, So let me see if I can get this thing to load. And it's like not wanting to load. And I can't figure out what is going on, why I can't get it to load through there. Jesus. Okay, that at least got it to go. So, yay. And of course, not having a clear tube always makes it fun when you're trying to load filament. Always makes it fun when you're trying to figure out where your filament is. And this is where I'm saying I need to get a compression fitting here because it keeps pushing the PTFE tube out. Okay, how goodness gracious, I have no idea how far I need to go here. It was continuing to feed, but it shouldn't be a 800 millimeter long run. Okay, I'm not sure what's going on here as to why we're not getting any filament out, but I mean, I've run quite a lot. And I'm still not seeing anything coming out the hot end. But there should be more than enough. It should be to the hot end by now. I have no idea what's going on. I mean, it is pulling filament. I just have no filament coming out the hot end yet, which is killing me. Ah, there we go. We finally got filament coming through. And of course, our bowden tube is pushing up and out over here because I don't have it clamped down. So that's going to be an ongoing issue. And I'm going to have to get that fixed. So, I don't have the color I want, but I can do it. Yeah. Give me 1 second to look something up here real fast. Yep. We're going to start heating up the V0 and I will print that replacement part. It shouldn't take that long because those parts are really small. So we'll go ahead and chat. What I'm going to do is I'm going to print a replacement, this piece right here, the front channel piece, and that will basically it'll be one of these two here that I can either screw a coupler into, or in this case, it'll be a press fit coupler that will go in there. And I'm going to print one of these, and we'll basically just have to rebuild our extruder real fast. But it'll be able to clip on the bowden tube and we'll be fine. And I may swap it out for some clear PTFEs so that I can tell where it's at. I mean, the blue does go well with the build, but I hate not knowing where the filament is. I can't tell. It's not really bad karma points. It just is what it is. So I'm going to go ahead and do a filament unload. We'll try and back it out some. Let me see, G1, E, negative 150, or actually, let me see. If it'll do that. Seems to be. I mean, I could rebuild it with one of these, but then I just throw the color scheme completely out of the whack. Yep, the life of 3D printing. It is what we have to deal with. Yeah, so what I'll do is I'll reach out to Fabreeko through Discord and be like, hey, here's what's going on. Here's a picture. Can I get a new cold side? Because I really don't need the whole thing. I just need this portion right here. And I can undo the screw and swap this over onto it. I just need that piece right there. Okay, now we're going to do that, but we're actually going to say like, let's go a little bit faster here. Oof. And then what I probably need to do is try and come up with a measurement, fix my filament load and unload macros with a correct amount. Which is really, I mean, like measuring your bowden tube, adding a little bit, and then calling it good. So we're good there. We can turn this off so that our fan will go quiet. Ooh, the other thing we need to do that we can do while we're waiting, thigh plate's finished, is we'll need to do our bed screws adjust. So gonna move things by hand real fast, do a home all. And I can probably change the settings on that sensorless homing a bit. It's still there's a on your sensorless homing, there is a correlation between your homing speed, your motor current, and your threshold values, right? So anytime you change the current or the homing speed, you're going to probably need to change your threshold values for when it knows it's hit something, right? So that's why you see it come over and hit, and then you'll see the belts get a little loose as it kind of, I'll say, racks a little bit before it stops. So that's where I say I need to fine tune that stuff just a little bit because it's making those, it's not sensitive enough right now. Okay, so we did a homing. Let's go ahead and go back. We did our two PID values. And now next step would be bed leveling. So on a V0, it's bed screws adjust. So we do manual bed leveling using the paper test. And so we need to run the bed screws adjust. And let me just show you real fast in the printer config here. I'm going to scroll down past our motor values, the bed section, and then we get to homing and gantry adjustment routines. So we've got Safe Z Home. So this is where it knows to go to all the way to the right and then all the way back. I can change this to more right in the center of the bed. And so it will home and then come to the center of the bed and then home the bed down. And then I can make some other changes. There is a macro here, this homing override macro that was there before, that I think brings the bed back up at the end. So home Z then goes, yeah, it'll center the X, center the Y, and then bring the Z up. So what I'm probably going to do is comment this one out. And then uncomment this macro, which is the macro that Fabreeko sets in their config file. So bless you. Okay. Oh, is that for my cough? Sorry. So we're going to run a bed screws adjust, and it uses this portion right here, this section. And what it does is it tells you where your screws should be. So it should come and probe right above all of the screw points. If it doesn't, we can adjust that and make it closer. But I think that's going to work because it's the same adjustment points that I took off of my other Rook. Oh, you don't see the screen? I'm sorry. That would help, wouldn't it? Sorry. So, yeah, what we've got is I was running this Safe Z Home macro, and what that does is it'll run X, it'll run Y to the right in the back, and then home Z, and it leaves the bed down here at the bottom. With this homing override macro that Fabreeko adds, it will do the same thing basically. It's going to look for the max for X, Y, and Z. It will home X, it will home Y, and it will home Z, and then it comes up and moves everything back to kind of the center and moves the bed up, which is probably a little bit better thing to have done anyhow. Then on bed screws, this is the macro that we're going to call with bed underscore screws underscores adjust. And that's going to move to the 3 points right underneath the leveling screws so that we can then trim the bed to our tool head. Okay. So that's what we're going to do now. I will do a save and restart real fast because I changed that homing macro. And then I'll run that homing macro so you'll see what I'm talking about. And I'll just kind of move everything to the center manually. And then I'll say home all. And then it basically goes to the center. Okay, so this is a little bit better of a homing routine, right? And then what we're going to do is we're going to run our bed screws adjust using the paper method again. And everything's cold, right? So we're going to take our our piece of paper, and we're going to be ready to run our bed screws adjust macro. And it's going to go to the front first. So we just put our paper in here, and it's very loose. So we're going to turn our knob. If we turn it to the right, it's going to tighten up. We turn it to the left, and it will loosen up. And we're just going to get it till it starts to pull on the paper. Right, we're getting some tension, and I'm going to say adjusted. Then we're going to come over to the left side and do the same thing. Now that one's already touching, and I can't move the paper, so I need to tighten this one up some. I'm able to move the paper now, so I'm going to back it off just a smidge. And I'm going to say adjusted, and it's going to go over to the other side. And now I'm going to have to try and get in here, and I can't. So I'm going to crank down on the screw until I can get the paper underneath there. The paper's in there now. Now I'm going to set tension on the paper. And I'm going to say adjusted. Now notice I'm saying adjusted, and I want to run through this once or twice, because every time you adjust one of these, it's going to throw the others off. So see, this one was tight before. It's not now, because we raised the back, or we changed the back, which changes the front plane some. So we're just going to, we need to untighten the front screw. So we'll turn it, counterclockwise. Is that right? No, clockwise. Okay, we'll say adjusted. Move our paper over to the other side here. And make sure we're not at the folded piece. And we're going to start working on it again. No, not yet, Zombie. We've had a couple of issues. The Rook hotend that came with the kit has an internal milling issue. And I'll show you what I mean here in a second. Right now we're just trying to level the bed. Yeah, I'll show you what I'm running into. And so now we've got a little bit of resistance, so we're getting a lot closer. All right, I think that's good there. Just going to pre-position my paper back here and say accept. You want to do this 3 or 4 times the first, just to get it real close. And your adjustment should start getting a lot less. But as long as you say adjust it on one of the 3 points, it will continue to go through the process. And I like that there. So we're going to say accept, and we're good. So we've now trimmed our bed to this particular build plate. So when I go to switch it out and put the nice Honey Badger build plate, I'll of course have to retram it, but we're good for now. Yeah, so what's happening, Zombie, is there's a milling issue. If I take a small piece of PTFE tube, which, what did I do with the small piece of PTFE tube, people? You guys see what I did with it? Oh well. So anyhow, when we've got the PTFE tube in here, there is a bit of a ridge that hangs up on the filament. And when I'm trying to extrude, it winds up doing this to the filament. You see how it kind of knocks it off to the side? It's kind of hard to see there. See how it's jutting off to the side there? And yeah, it wasn't flat. I had to tram the bed for the first time. But this little piece of plastic is getting pushed to the side because the filament path is not straight. And I figured, okay, so once I figured out, and it's up here on the cold side that it's hitting. So it's a transition right here, kind of at this point of the tool head, where it goes from the PTFE tube in. And I thought, okay, well, maybe this requires a chamfered edge versus a flat edge like you get in the E3D hotends. So I grabbed a piece of tube from there and put it in there, and it was a little bit better, but it's still catching on a ridge. And then I built this one. This is one I had when I was doing the Bugaboo. I think I bought these. And this doesn't have that same effect, but you know, I'd really like to use the Rook hotend for this. I'd really not like to use a different hotend. And right now, that's why you see my wires a little jumbled up here, is because I've installed a Revo CR, which is also it's longer than this tool head, which means I'm going to have to print a different shroud for it if I leave it on there. And if I go for this tool head, if I line those up with the mounting points, it's longer as well, but not as bad. So either way, if I can't get the Rook one, then I'm going to have to redo some wiring and play around with whether or not I have to print other shrouds. So we're close to pushing plastic with the Revo CR, but I'm still having issues here where the PTFE tubing, there's just not a good enough friction fit on it, and it's pushing out. So the Boron V0 is now up to temp. I just need to find my Sherpa Mini files and print a new piece. It's not going to be the right color, but And of course, it would be 2 hours because I've got the full part set, not just the one piece. So, you know what? Yeah, we're gonna take this off and we're gonna rebuild it real fast using this part, and I'll reprint it later, because I don't want to continue to sit here and wait for a print. So you got to remove your thumb screw so that you can get to the mounting screws on the side to take it off its mount. Yeah, so the bowden is attached to the tool head with, of course, a standard bowden coupling clip. But in the back, normally, like I've got it friction fitted on a couple of printers, and it works fine. But here, it's just, yeah, it's not working. So yeah, this sucks. Yeah, I'm gonna have to undo the motor and the front. Basically take it all apart. So let me get the motor off. We'll just set the motor up there for the time being. And then we can take this apart and we're going to rebuild it. Like I said, we're just going to swap out the main core piece for now, and I will print new parts. Because I want the color coordination. Front plate comes off. Either comes off. We need to take the main filament drive screw off. Means we need to take our set screw out. Get that off. Then we can take this piece off, and we'll need to put in a couple of heat sets on this piece, and then we'll be able to go. So let me do a little bit of cleanup real fast to get this stuff put away, to make room so I can solder without making a mess. Or not solder, but get the soldering iron out without making a mess. And now technically we've taken apart and we are rebuilding the extruder. So there's going to be that word again. Technically, we would have to redo our E-steps. I'm not going to redo E-steps. Yeah, I will rebuild this down the way, but is what I'll do is I'll print one set with the lime green, which is what's loaded right now, and then I'll do another one in the blue, which will then give me the color scheme that I need to make everything work. All right, we got that. Let me put the longer screws in. Here I was expecting, okay, it's going to be a short stream. We're going to be pushing plastic real fast. All's going to be right in the world. And then we're not. Put our drive gear back on. Make sure that it lines up with the filament path. And tighten it to the shaft there. Make sure everything still moves well, which it does. It is lined up. Now we're going to line up our other pin piece. Just going to slide in, slide in, slide in, maybe. Make a liar out of me. Here we go. So that pin went in. Things should be meshing well. Use filament just to make sure that things are lining up. And they are. Now, what I didn't do is run a bit through here to make sure that it was nice and clean. So we'll do that real quick. Those have to come at from both directions. Real clean from the top, but not the bottom. Okay. Now we'll put our other front piece on there. To line things up, use our two small M3 screws. All right, so that's good. The top here, I believe, like a screw, or I believe it's an E-cast. So I believe they call these E-cast. They're press fit connectors, and you see inside of them, they've got a metal ring, and that's what latches around your PTFE tube. And these just snug fit in. Your PTFE will go down in there and be a tight friction fit. And like I said, this design has a mounting point right here where you can put a end stop, and it becomes, there'll be a screw that'll go through a modified lever arm here. And that one screw will be your tensioner for your lever arm for your filament. The other one you will then set to barely trigger the end stop. So when you put filament in, it rocks out just a bit, and the plunger on your end stop opens up, and that will then be your filament end sensor. So whenever this rotates back in, when filament runs out, it'll know that you just had a filament run out, and it'll stop your print so that you can address it. One side of the motor, and what I'm going to do is I'm just going to, that's going to prevent me from doing it. So I'll rotate that motor down to make sure it's making contact. Make sure that it's not overly tight against the plastic gears, because we don't want it to, one, chew up the plastic gears, but also two, we want a tad bit of backlash in the mechanism so it doesn't grind that gear. And mounting screws back in. Yeah, I probably did that to myself, didn't I, Britt? Yeah, this will be a short stream. I figured out the last part of the software at like, well, I was up till 3 o'clock last night trying to get the Banana Pi board talking to the controller board for the printer. Went to bed, still couldn't get it figured out, and I realized this morning, I was like, well, let me try one other thing. It was a last ditch effort, and if it didn't work, I was just going to have a Raspberry Pi 3 sitting on the side, and we'd just run a USB cable, right? I was like, I'm done with it. We'll run it that way. everything but my tensioning screws in. So I'll have to put that in. Make sure we don't lose our M3 washer in the process. So anyhow, what it was because I was connecting via UART rather than USB, you have to, one, reflash the firmware on the SKR Mini E3 board, which I did. And then you also have to, in Clipper, let me bring that up and show you all. Okay. So in Clipper, the other thing you need to do is know what serial port is exposed. Now, if you've ever done Octoprint, you normally will see /dev/tty/ama0. That's the UART port that's exposed on a Raspberry Pi, regardless of which Raspberry Pi it is, right? Well, the UART console port that's exposed when you do the same pinout on the Banana Pi is TTY-S3. And I was seeing things where it says it defaults to a baud rate of 115/200. So that's what I set in the firmware. Well, then when I was querying the actual board settings, I was seeing that it was setting the baud rate to 1.5 million. I was like, well, that's funny. So I redid the board to 1.5 million. And it still didn't come up. And I was like, what is going on? Why is this not functioning the way it's supposed to? And I don't know if it's a new setting in Clipper or what have you, but I wound up having to set right underneath the serial there. You'll see there's a baud : space 1.5 million. As soon as I set that and restarted my firmware, it came up. So I was like, really? So that was it right there, was setting the baud rate in Clipper config. The other thing I want to do real fast, since I have this out, I'm going to do a little bit of a guesstimation. I'm going to hold this up and I'm going to try and figure out. So there's 300. Okay. So my filament load and unload macros are woefully not long enough. But so setting this right here made it work. So now knowing that, I think I can get the RADSA. I think that's, yeah, the RADSA 0 board. This other board here, I think I can get this one working. And once I get this one working, life will be all good. It'll be roses and cherries and everything, and everybody will be happy. Okay, so bowden tubes in, and it's not coming out. So next up is closing this. We're going to go over to our macros, and we've got a print start, we've got a print end. I have no clue if those are even remotely what I want, but I do know that a filament load of 30 is not going to work. So we need to change this to like 450. Or actually, let me rephrase that. So we're going to do a fast, then a prime the nozzle. So, oh yeah, 450 should work. 450 would get it close to the nozzle. And then we're going to extrude another little bit, but we're going to do it a lot slower, right? So that's where we want to prime the nozzle. And if you're ever doing a filament load and all of a sudden you hear it hit and it kind of goes, that means that your length is too high or too long. You need to pull your length back because it's trying to go fast. And basically what you just heard it do was grind the filament in your extruder, which would be bad, right? So we changed it up here. We need to kind of do the same thing back here. So we prime a little bit, then we pull a little bit real fast. And then we want to actually go through and do an actual filament remove macro. So what I'm going to do here is just do G-code macro. So this will be filament remove, close bracket, G-code, colon. We're going to do a tab, and we're going to set the extruder to relative. And actually what I'm going to do is I'm just going to copy a couple of these lines, throw it down here. We're going to get rid of the extrude a little line because we won't need that now. Our intent is we've already done our extrusion or our words. So we've already done our filament unload or our unload filament command. Now what we're doing is we want to be able to run another macro that fully extracts it all the way back through to the extruder. So now we're going to tell it to pull it out 450 millimeters. And we probably don't need to go that fast, but we're going to have it go like 500, right? Because we're pulling it out of the extruder or out of the hot end. We're not worried about it like hitting the hot end and trying to purge at 500 millimeters a second. So we're good there. So we've got that done. We're going to make that clean. We've got this here. And you notice that I changed the order. I'm going to do the same thing here. And I do this because what it's going to do is put them all together at the front versus in various places throughout my macro list. So it's more of a convenience factor for me. And I need to double check real fast if my macro or my G-code and Prusa slicer is set to print start or start print for the Rook. Because there was a point in time when it was print start and then it went to start print. Print start is correct. Then what I would be able to do is come in here and say whether or not that's the correct print start G code for me. But what I would do is grab my other Rook and copy and paste those over. But I'm going to just save and restart here. You'll notice when I come back to the dashboard and it loads up, if we come down here and look at our macros, we've now got filament load, filament remove, and filament unload, and they're all three together rather than being spread out. And we don't have a lot of macros here, but it just makes it a little bit easier when you are running a bunch of macros on a printer to have certain macros grouped together versus spread out. So that's something to think about, like your print start and print end will be right next to each other. So it just makes it easier. And then the other thing I'm going to do is, what was UI? It wasn't UI. Dashboard? Yes. Move that over there so it's easier to get to some things. So I believe we need to heat up the hot end. And I can probably add that into the macro as well to heat up the hot end as part of the filament load and unload macros. That will make life a little bit easier as well. And what I can do is my my orbiter extruders. We've got so the orbiter extruder has a filament load and a filament unload, and they're based on button presses, right? So on the extruder itself, it's got a button next to the filament sensor, kind of up in this area. So you push that button and it goes, oh, you want to unload. It will heat the hot end up and then it will do the unload sequence. Same thing when you put filament into the sensor, it basically has a ball that pushes a button inside the housing, and that's where it triggers and goes, oh, you just pushed a button because you put filament in there. And it goes through and it will pull the filament towards the hot end, heat up the hot end, or excuse me, it pulls the filament in a bit so it makes sure it's through the gears. It pauses, heats the hot end up, and then it will purge through because most of it's direct drive, and it will purge out a bunch of filament. So you can go in and basically copy and paste those filament macros into any other printer, and you'll have a good filament load and unload as long as you've got some way of triggering it. In this case, we just call the macro directly rather than doing a button push. I hope that makes sense. I kind of rambled around a bit. So we're getting heated up a little bit. Once we get heated up, which boom, we're at 190. I'm going to go ahead and say filament load. And it should kick in and start pulling our filament through at a somewhat rapid clip. It's not like really kicking it. And then it should change. Okay, and there it just hit and kind of ground and stopped. Yeah, so I think I just added too much tension to it. So that was me. Okay, so we did have some time where we overpowered the motor. I really need to look up this motor and see what the current is because I may have the current actually set too low right now. But we are still heated up. We're going to go ahead and say extrude 50, and we'll see if we can get some filament to come out our hot end. And if so, then we'll try and slice something up and print something. Yeah, that motor's stalling out again. All right, let me turn this slightly so I can see the motor, and I want to pull up the motor parameters real fast. HB 36H. That's 20. 18. 36 HS20. Dash 1018 dash 18. What I'm trying to do is figure out what the specs are of the motor so I know how much current to set for it. And it doesn't say, so all right, we're going to do a little bit of side-by-side action. We've got one rook there. And one rook here. Get this plugged in. Okay, and what this is going to let me do is just compare to the other Rook here. It's not the same. Oh crap! It's not the same motor. So nowhere near the same motor or same extruder. So that's not going to be right. So let me look at. A couple of my other Sherpas. See what I have those motors set to as far as current. Yeah. One I have set to 3, another I have set to 5. And with this stalling out, I think I have it at 3. So I'm going to go ahead and extruder run current set to 3. I'm going to go ahead and up that to 5. Save and restart. Our temperature back up. And we'll go to 200. How's it going, Westery? We've got side-by-side rooks. And we're going to do an extrude on this one again. And we do have plastic coming out. There we go. That was the case. I just dropped it down too much. It was at like 0.7, which was way stupid crazy. I mean, that's a full NEMA 17 like I've got on the back on the bot, you know, the pseudo Bondtech that I have back here for the Gold Dragon, the other Rook. So having it this way, I think, 5 should be fine. It's not getting hot or anything. Now the next thing is like, oh, well, we need G-code files. There's no G-code files here. Like, why do we have no G-code files? Well, let me upload some G-code files. I have some of those. Here's my switch. By the way, hey everybody, that's here. We'll do some shout outs here in half a second. Let me just try and get a couple of files uploaded. I got to do it over on the Mac because all of the files are over on the Mac. And by all the files, I mean all the files that were previously done for Gold Dragon. Everything should work the same. So I should be able to take anything that was previously sliced and move it over. Which apparently wasn't a whole ton. And you do notice that we've got the nice build plate here. We've got a cruddy one over here. I do have a nice honey badger textured surface plate that will go on it. I just didn't want the first attempts with a nice pretty plate. So we will, yeah, we'll go on the plate that's already had some damage to it the first time around. Hey, Pez. Do I have another? Do I have another? No. I was looking for another spool holder. Oh, there we go. I mean, if we're going to sit here, we've got two side by side. We might as well see about printing stuff side by side, huh? What else we got? We're not going to use that gray. That gray was garbage. ABS, 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 ABS. Nope. Gold. Yep. So I will, like I said, I will run the honey badger plate on it once I just get a couple prints through it and make sure that everything's working right. I just don't want to gouge that plate. Because that would make me cry. Okay, so yeah, let's we got files. So because we have files, let's just try Swatch Truck. We're just gonna send it, see what happens. We are just going to send it, and then we have Gold Dragon here. So you'll notice that I've modified my color scheme a bit. So you'll see there's a blue up here for the mainsail logo, and then you're seeing the lime green around here as well, like you see in the language and the bars and stuff. So what I've done is in the customization here, one, we gave it a name. Thank you, KB3D Chris, for the suggestion of Ragnarok, which isn't dragon related, but we'll go with it. And then I believe it's UI settings. You can come in here and you can change your color scheme, right? So what I did was I went out to Polylight's website, or Polymaker's website, and I said, okay, I used blue and green ABS. So I got the hex code for the green, just did a quick hex to RGB color converter. You put in your number and you'll get your RGB values that you can then come in here and put in. So you just put in your RGB values for your color scheme, and voila, you've now color coded your mainsail UI to match your printer. Yep, they are multiplying. That is true. And what I want to do is we'll have them side by side. Oh, this is that. So the other thing I want to do while I'm sitting here, so I want to look at my macros. So filament load 500, then a 40. Filament unload. And I do a full unload here. And start with a prime line. Yeah, I will probably copy this macros file from one to the other, just to make sure everything matches up. But what I'll look at doing is, after we get a swatch truck going on here, well, actually, I'll get it going. I was gonna run them back to back, or kind of like a race style, but we'll go ahead and. No, not that dragon. I thought I had a Cali dragon on here. There we go. Cali dragon. Yeah, after we try and do a swatch truck on this, then we'll try and do a Cali dragon. Okay. Yeah, I didn't think we were primed well to start with, so we did get, but I'm gonna let it go. So it didn't look like we were primed well. There's no prime line at the start. Once again, this is using the start G-code macro that came with the Fabreeko kit. So it does miss a couple of things. So I will convert that over to the same start macro I have on Gold Dragon. And we'll get to hopefully have a little bit better beginning prints here on it afterwards. Ugh. Yeah, this one is heating up. Well, it seems to be doing good. Let's see what we're looking like here. Let's go to this view and let me move some of this stuff out of the way. So we'll have racing rooks today. And yes, they are multiplying. While these run, I'm going to step away just real fast and see if I can't get my missus to start me another cup of coffee. So I will be right back, folks. I'm just going to mute the mic. Okay. Hope you all didn't miss me too much. No crying and building 3D printers. Yeah, I can go with that. I say you're going to see a grown man cry all the time because one of these days you just might. If I have to keep crimping SB2209 baby connectors, but really this, I think the wiring job on the Fabreeko Rook went really well. Like I said, I'll have to get the hot end fixed or figured out. But beyond that, I mean, we're going to have imperfect cooling on it unless if we leave the Revo CR on here, then I need to print a new fan shroud. If we go with something else, we should be good. Okay. So I need to pause Gold Dragon real fast. No, seriously, pause. Or not. Apparently it has a pause command that it does not like. You guys see what happened there? Because I didn't. It seemed like it started getting a little print booger there. It was going to cause problems, so I stopped it. Okay. We'll try and get that started again. Yeah, so I'm still dealing with that slice right there on the finger, and it's still a little and feels like it's a little swollen and infected. So I'm going to clean it out with some hydrogen peroxide today after stream and throw some antibacterial ointment on it, see if that doesn't help. But let's see if these break away like the others did. Oh, no, if I let them sit overnight, I have literally had these prints where the brim has stayed on the printer and the supports came off, still attached to the printer, and everything, the part itself came out without any problems. But as it is, the brim for the most part peels right off. And these are hip plates. So I guess hip plates for the Imperial armor. So all my leg pieces are now printed and done. I'll be moving on to, I don't know, chest or jetpack or something soon. So we're getting, our parts are collecting. Why are you getting, yeah, that didn't work. That made it worse. But our swatch truck over here is going together. I don't know if it'll move, but we'll see. Considering it's the first print, and I don't know if we've got our first layer height dialed in well or not. Ah. So why were you crying, Liz? Hope it hope it was nothing major that was causing you to cry. Yeah, I think it's just the initial blobbing, and then it was like an initial blob that then caught on the brim. So it should recover past it. Is the right build plate okay? This build plate? This build plate has, we'll just say it's got stuff embedded on it that's not coming off unless I peel the sticker off. So that is a junk build plate, and we will eventually be swapping over to a honey badger build plate on the Fabreeko build. But we just threw a junk build plate on it so that we didn't gouge up a pretty new one. It's kind of a thing to do when you build printers long enough. You're gonna gouge a build plate, and having the ability to use a jacked up build plate when you're testing out like sensorless homing and like bed probes and stuff like that. It's always a good idea to have a junk one that if you tear it up, it's already tore up, so it's no big deal. I got you. Yeah, yeah. Blobs of death. So I will tell you that this printer right here, Golden Dragon, this one went to Murph. We lost the power brick. The fuse in the power brick died at Murph, which is weird because it had been printing for that long. And all I did was buy 2 new of these power bricks, and I've been using it to test this one. And now that we have this one fully assembled and we've got the actual power supply that's underneath it going, I just plug this into my Rook here, or Gold Dragon, and I figured I'd run them side by side. So you're getting a chance to see both Rooks printing at the same time. And you've got the black and gold color scheme of Gold Dragon and the blue and lime color scheme of Ragnarok. And we're doing a swatch truck over here. And this swatch truck is the same exact file that we had sliced for Gold Dragon. So yeah, no changes there. We just took the file off of Gold Dragon and put it over on Ragnarok. So easy peasy. Um, what do you mean by any good models for the V6 Revo? Are you talking about so you're talking about like extruder mounts? Because if you've got a V6 Revo, then by definition you've got that grove mount, the round grove mount that it clamps around the top, and by definition it's a drop-in replacement for an E3D V6. So any mount for an E3D V6 in an orbiter that'll fit on a Kaiwu will work. And that's literally what I did. Was I took a Mark III tool head from a Prusa Mark III and created a mount for my D-Bot tool head, which uses a 2040 X gantry. And I just figured out the right drill pattern for it. And I basically was running a Mark III tool head on my D-Bot, and it was running a Revo 6 because it's a drop-in replacement for the E3D V6. So yeah, I would assume that somebody would have come up with a E3D V6 mount for either the Kaiwu or something that has a similar gantry. But I'm not familiar with the Kaiwu or the Tycoon Max. No one's modding their Kaiwu that much? Okay, so let's do a quick check. I guess I could do it over here. So go for a Kaiwu Tycoon Max. Okay, so the Max is the linear rail on a flat bar. And it kind of mounts the extruder right above the tool head. Oh yeah, definitely. I mean, that's the thing is if you start changing too much, you're going to have to do a lot of other mods. It's never just one mod. It winds up being, well, I changed that, so now I need to change this. Yeah, I'm just looking at pictures on their website, and I don't get any real good pictures of that linear rail setup. If you could provide a couple of good shots of, take the shroud off and show me the linear rail setup and kind of how it's mounted. Put them out there on the Discord server or something, John Strand, and I'll try and take a look at it and see what may be feasible and what kind of mount might be easy to mod. Which way is the rail facing? Is it up, down, or facing the front? because I can't tell from the photos that they've got here. So it's facing the top. Okay. Okay. And is it a MGN 12HC? What carriage is it? Do you know? Yeah. So what what kind of carriage is it, and how are the belts routed? Yeah, I'm assuming that if the rails hard mounted at the top, then the belts go around the front and back of the whatever the rail's riding on. Okay. Yeah, most likely I'll be an MGN 12. Hmm. Yeah, I don't know. We'll have to definitely look into that and see what we can come up with. I'm trying to look and see. I mean, the heat block, do bang Discord and chat, and it'll come up with my Discord server link. Hey, MewP78, thanks you for the follow. Thank you for coming. Yep, there you go. So I'm looking at the heater block, which looks like a standard Creality style heater block. And if that's the case, then I wonder if it's just a case of swapping over to a versus a Revo 6, get a Revo CR cold side. Yeah, but you can buy just the heat sink and everything else just transfers right over onto the heat sink. Because I've done that in the past where I've had a micro, but I needed something else. You just buy the heat sink and swap it out. It's like a $30 part. But then it'd be, okay, how do you mount a how do you mount an orbiter to it instead of theirs? I'm surprised that there's no things on Thingiverse or anything like that yet. Yeah, so you can go out and just buy the like go to KB3D. I believe they have just no. I think KB3D only has the full package, not the just the CR heat sink. But you can go out to Amazon or Fabreeko, Printed Solid maybe. Just look at all the major vendors and see who has the CR, the Revo CR cold side. Technically, the Revo CR has a different thermistor, and it's made for a drop-in replacement. But I mean, that's no big deal. Just change the thermistor type in your firmware. You're going to have to make firmware changes anyhow. Yeah, that's the main difference. If you do the Revo CR and buy the whole package, that's why the thermistor wire is yellow. It's because it's a different thermistor as a drop-in replacement for Creality box. Yeah. You can drop it anywhere. You can drop it in general chat. That's fine. I don't have a full set of, mod my printer channels yet. Ooh, I'll be right back. I need to finish brewing my coffee. Give that a couple of seconds, and then I'll have to run back downstairs and actually get it. Yeah, so if you do a yeah, like yeah, so a quick look is, there's Matter Hacker has the full setup for 92 bucks. Printed Solid has the heat sinks for 25 bucks. Philips same thing. It's about 25, 30 bucks for the that cold side heat sink. And it's got the rounded fin front edge. It gives you larger cooling capacity, but it is a flat mount on the back. Okay. Yeah, and I don't think, for some reason, I don't think KB3D has. Yeah, they've got the boron cold end. They've got the CR full package. Yeah, so it looks like it's just the um like the boron uh heat sinks that they have. Everything else is the full kit from KB3D. Yeah, it's definitely a MGN 12H rail. Hmm. And that plate is the plate where it looks like the extruder sits on. It mounts. Oh. Okay, so looking at the plate, the belts loop around the pieces on the back side of the rail. It mounts to the top, and then the motor for the extruder is basically sitting right on top of the HGN 12 carriage. Okay. Okay. Let me think. Yeah, I'm sure somebody could model something up. I mean, because everything else I can think of would be kind of a kludge to get a like a front mount plate that you can mount things to. Because my immediate thought was, okay, it's similar to mounting an MGN12 on a Ender 3, right? Um, by the way, this finished. So there's our swatch truck. I can pretty much guarantee that it's not going to move or the wheels won't move. Um, you need to look at the back here and see. I think we're still a little high, but nope, we got one to break loose. What was that? The 0.3 broke loose. The 0.2. Yeah, I don't think that's coming off, and the 0.1 definitely isn't. Looking at the back, I think we had some issues initially getting our filament going. But I think we were close. So shall we switch over to the honey badger and try again, or do we stay with the same plate and hold off on the honey badger plate just a little bit longer? I think we'll stay on this one. Hold off on the honey badger just a little bit longer. We might have to go down just a shade, just a scotch. And let's go ahead and I want to grab a few macros. Oh no. Start print in. Okay. Cancel, resume, pause. And end. Click start. Element unload and load. We don't need. Yeah, you may have to, because the only thing I'm thinking of is really it's going to be, oh, dang it, that's not the dragon I want. I wanted the calibration. Why do I not have? Sorry, folks, give me 1 second. I want the Cali Dragon. Um, all right, we're going to run another Cali Dragon over on Ragnarok. But yeah, the only thing I can think of there is, um, some type of ender setup because the belt path, the way the belts hook are similar, but the belts in your case are going on the back side, not the front side like they would on an ender. Um, so yeah, that's the weird spot. You like I said, you're probably gonna have to fire up Tinkercad and do something in Tinkercad. Um, I'm trying to think what all uses a top-mounted rail. Yeah, that's a good one. I don't know, John, right off the top of my head. I'd have to really check into that. I'm going to step out right quick and go grab my coffee that should be finished now. Ah, second wind. Got coffee. Oh wow, no belt tensioners. Oh, nice, Britt. Yeah, as I said, I was up until like 3 in the morning, um, working on the printer, trying to get things cleaned up, and it was a little rough. Not gonna lie. So I will say, Britt, that we printed some plastic. We did a swatch truck. Um, Only the point 0.3 was moving. I can't get the other two done. But looking at the back, I think it's an issue with my initial settings. So we're going to try and get that dialed in a bit. We've got, no input shaping done, no pressure advance, none of that stuff. It's just, we calibrated E-steps. That was it. So we haven't done any extrusion multipliers or any other tuning. We're just printing with it. Yeah. And looking at that, that was, yeah, I think we're a little high. So I'm going to squish her down a little bit. Oh no, we're way high. And now we've broken. So we're going to stop that print. Let's home all. That was weird. And the bed did that for a reason because I did a stop on it or saved config because I tried to drop the parameters down some. Tell it to go ahead and print again. And we'll get that print started again. Meanwhile, let me see about cleaning this plate a little bit because it's been just kind of sitting there chilling. So we'll see if we can't get um, a better print actually going on this. And while I got stuff out here, I might as well go ahead and clean the honey badger plate. I have a feeling people are going to want to see that soon. So we've dropped it down a little bit. And then the other thing I'm going to do is slow it down a little bit. Give it a little bit of extra time and slow it down on these first layers. Oh, looks like it might be a little bit high. So the layers are getting better. Now, as long as it stays stuck, we'll be okay. But you have seen I have dropped it a considerable amount. By considerable amount, I mean almost like 0.1. Actually, it looks more like 0.125. So I think we're just still way too high to start, but we're getting down there. But as you can see, this is at 75% speed. They can go pretty fast. I mean, this is a smaller print too. I'll go ahead and keep the speed back up to 100%. I just needed some more time to figure out whether it was a layer height issue or not. Britt, hope you're doing well. Hope you've got some squirrel sightings. I know I've seen some cool photos lately. What was it? An otter. There was one on. It was like a little video clip on Twitter of an otter, and they had its head right in its hand, and they were just kind of rubbing the back side of its head, and he started yawning and everything, and I was like, oh my god, that's so cute. And I've seen a couple of squirrel ones like that too, where the squirrels are very, very friendly. I'm doing good. Doing good. The wifey is home. I had to go and make my own coffee because apparently the wifey is outside doing something in the yard. But she did come and brought me my Dunkin' run this morning. So I got coffee and, of course, the Munchkins, which the assortment was not much of an assortment today. But I did get my Dunkin' run. Did get my Dunkin' run. Other stuff going on. I got another printer that arrived yesterday, and I know that shocks everybody. Yeah, well, that's okay. I mean, it is what it is. Uh, I really am not supposed to be eating donuts anyhow, but oh well. Um, but we had another arrival here in the Dragon Den, and it's just a plain Jane Ender 3. And this Ender 3 is going to be the donor for the Ender belt conversion. And in fact, I'm going to go ahead and open it up because I hear things moving around in it, which kind of makes me feel like it wasn't packed very well. It is a used printer off of eBay, so it's, I'm not expecting perfection here. Actually, I'm hearing something moving around. So the bed's not fully mounted, I'll say. Or maybe it's just the, okay, it's a couple of the bed screws came off. So that's what's moving around has been the bed screws. But it's got the OG, I'll say plate with bulldog clips. So this is reminiscent here. So, and we've got an issue. This is not good because it's not going to be pushing appropriately. I mean, it's pushing the filament out here. It's not pushing it out here. So we're going to stop that. And then I'm going to shut off the motors, which will cause the bed to drop. And we'll need to fix this. That was kind of interesting. I didn't think it would be able to push out the this bowden tube. Darn it. Yeah, the wires are messing everything up. Seriously, that's not even. There we go. Get back down in there. I don't think these take clips. So I don't think that particular design does. So that was weird. Yeah, looking at the bottom of that, you can see that we were way high. So, all right, well let's save config. See if we're too low now. Actually, what we'll do is we'll go up a hair's breadth more. Yeah, but that's the I'll say that's the old school build plate. This is what mine came with. Is this like fiber? I don't know. It's like a fiberglass. It's got a little bit of spring to it, but it's kind of like um, a build tack sticker on top of a piece of like nylon board or something. And yeah, these are messing with me. I don't know. It's doing something weird. So we're hot. We're gonna do a short extrude if I can find the extruder. I just want to make sure that the nozzle's good. Okay, we got some more fuzzy stuff out down here, so we're good there. Make sure it's all cleaned off. Our Cali Dragon again. Yeah, after stream today, I'll be opening up this Ender 3 just to make sure that I've got all the parts and nothing's really bent up. If it is, I probably have spares. Oh wow, it's even got the plastic extruder. Now I get to see it. The plastic extruder's busted up. Yeah, no kidding. Ragnarok, come on. Supposed to be better than this. So the way I have my macros set is it'll heat the bed up to temp, and then it'll heat the hot end up to 170, which gets the good start, and then it would do its whatever it needs to do, bed probe wise or what have you, and that just allows things to uh, start getting warm, right? And then it'll go through its whole shenanigans. But one of the other things I probably need to do is also do a input shaping on it for reels. Um, but that'll be a down the road type thing. It's weird. Yeah, the oozing from the extruder. The old prime line out of the way. Kind of like my first indication when my little prime line is really, really thin and squiggly. Yeah, that prime line didn't even stick. Boy, And we should have audio back. Sorry about that. So yeah, John, the whatchamacallit, the linear rail for the no, it wasn't muted. My battery died on the receiver end, so I just needed to plug in the external battery pack. So yeah, the linear rails for the V0 are really tiny. They're an MGN7, so that should be a little bit tighter. So we'll go ahead and do a Cali Dragon again, or attempt a Cali Dragon again. Yeah, so that would be similar to the 0G. They use an EVA tool head, but it's, remember, the belt pad for that is designed, one, to be on the front side as a Core XY style stacked belt system. Ah, and folks, I think I'm done for the day because this just pulled out again. And when it pulled out the metal piece that's actually supposed to clip on and hold the um, tube. So yeah, I'm kind of done. I'm done fighting with it for now. I will have to fix that off stream before I get completely frustrated. Yeah, definitely, John Strand. It would definitely be easier. So the donor ender was like 80 bucks, and that was shipped. So 80 bucks shipped. Exactly, Chris. Like I said, I don't know what's going on here. I don't know why it keeps pulling out and sticking and doing all kinds of weirdness. I'm just a bit frustrated with the troubleshooting today. So I think I'm going to call it a day, a stream, what have you. And exactly, the Congrower ones are around the same price. Um, we will, this will work. I guarantee you I will make this work. That's not the issue. It's just right now I'm getting a little bit frustrated, and I think I'm going to be better off suited to, like you guys said, go take a nap, go relax a bit, get my mind cleared, and then I'll come back to this and we'll work it out. We will get it working, but the printer is mechanically done. We need to tweak it some. I'll reach out to Fabreeko, but starting Tuesday, we're going to start working on the belt printer on Tuesday, and we will revisit this. I'm just going to work on it off stream, and we will revisit this. You will see this again in the somewhat near future as I continue to work on things. So yeah, don't fret about that. It will be here. Okay. And with that, gang, let's go ahead, and it's 4 o'clock. Let's take a look at a place to raid out to. Oh, wow. A lot of people playing games today. And not a lot of people on right now. It looks like Jerry 3D HP is just starting. Several people are playing games. Does anybody have a suggestion for a raid out? Okay, Timor, have a good one. You have to go start dinner? Okay, not a problem, John. Thank you, everybody, for being here. I will kick over to Jerry once he gets set up because I don't think he's fully up and running yet. Looks like Ugly Moo's playing World of Warcraft. It's File Mod's working on. File Mods is working on Big Boy Grip. Looks like it's a, I'll say a foam dart blaster. Yeah, first Fierce Kitten. Science. Yeah. I don't know. Oh, thanks, Westry. Yeah. Unfortunately, I would like both of them to be like, I don't know, printing and doing this, but I've got to figure out whatever's happening. Like I said, this should have been a press fitting that worked and it didn't. So the only other thought I can think of is pull the press fitting out. You see what I mean here? The actual metal ring, which is supposed to be the compression fitting, came right out with the tube. So that was weird. I'll have to figure out how to get that off. And then I'll have to figure out how to get that off. And we've got Nips to the rescue. And then I will literally try to just use a like a screw-in PFT connector. PTFE connector. I've got a bunch of them around here somewhere, but apparently none on my desk. So, but yeah, I'll grab a screw-in connector and just try and screw it directly in, and keep working on it. Well, I am glad that your Mini is working very well for you. That is awesome. How's the shield coming along? Were you able to get the rest of them put together? The rest of the pieces installed, I should say. Oh, well, I am glad that you are learning how to tinker, Westery, because that is exactly what I read right there is you've helped me tinker. Okay. Okay, so like I said, I'll continue to work on this. The I'll pull this press fit fitting out and just try and screw in a. I think it's the PTFE 10, I think, which is the one that the bowden tube can go all the way through. I'll do that and get that installed. And actually, I'll take that back. I'm just going to print out this in the lime green, which is almost done. Once that's done, I'll switch the filament, print another set out in the blue. So when I put this back together, it's got the right color combination, period. And I'll keep working on it. But when we come back on red, silver, blue, please, and thank you. So when we come back on Tuesday's stream, uh, we will be starting the ender belt build. Normally you start off with tearing the ender down. That's already done because it's in a box, right? If anything, I may have to put a couple of things together because it looks like the upper gantry was taking apart. So I'll have to put the upper gantry back together. But we'll work on starting that build. Okay, Vance, thank you for the follow. I'm not going to try and pronounce the whole thing because if that is your last name, I'm going to apologize because I would butcher it. But thank you very much, Vance, for the follow and joining in the stream. We're going to continue to do 3D printing and cosplay stuff. Westry, I don't think you saw my. These are the latest prints off. So other than a little bit down here that needs to be, this was the brim material and stuff, a little bit of sanding down at the base. I mean, that's not bad. ABS, these are the hip pieces. So the hip pieces of the armor. There are really no thigh pieces for this armor. It's hip pieces and then the lowers. So these are. I really need to figure out which is the front and which is the back. Maybe they go that way. I don't know. But the hip pieces are done. So this is all of the lower body parts are printed. I'm still going to have to spray them with a filler primer and sand them down and make them really nice and smooth. But I am going to start the next set. I haven't decided if I'm going to do like the chest first or the backpack first. Maybe do the arms. I don't know. I'll figure it out. and get those started here. When I get it done, I would possibly do a photo shoot, Westery. Yeah, that is a possibility. So bits and pieces may go to Earth. I don't know. We'll see where it's at by that time of that time of the year. But yeah, so Tuesday we will start the belt printer. Speaking of belt printers, I see Rob Mk of the Baby Belt fame is on Jerry's stream right now. So let's go ahead and raid over to Jerry. And yeah, thank you all for joining me. And we will get this thing working. I promise you that. So peace out, everybody. We'll see you again soon. And I'm going to take a nap and get some food. Okay, definitely Westery one. We're going to, what was it, Jerry 3D HP. Okay, thanks a lot, all. Yeah, nap sounds good. Coffee and sleep. That's that's the best thing. So let's roll over to Jerry 3D HP. Please follow me as we go over and raid into him. He just got started, so he's got only a couple of people there on, or at least on the Twitch side of things. So thank you all very much. Thank you all for being here and sharing your day with me. And I'll see you again on Tuesday. Have a nice one, now. Bye-bye.